Trigonometry is like a key that unlocks the secrets of triangles. It is a branch of mathematics that deals with the relationships between the sides and angles of triangles. Don't let the name scare you, it's all about understanding shapes. Trigonometry is used in various fields from architecture and engineering to music and video games. It helps us measure distances, calculate angles, and solve problems related to triangles. Imagine you are trying to measure the height of a tall tree. You can't climb it with a measuring tape. Trigonometry comes to the rescue. By measuring the distance from the base of the tree and the angle of elevation to the top, we can use trigonometric functions to calculate the tree's height. Trigonometry is also essential for understanding waves like sound waves and light waves. It helps us analyze their properties and behavior. Whether you are a student, a professional, or simply curious about the world around you, understanding trigonometry opens up a world of possibilities. Before we dive into the world of trigonometry, let's understand the basics of angles. An angle is formed when two rays share a common endpoint called the vertex. Think of it like the corner of a square or the point where two lines meet. We can represent angles using a small arc symbol. For example, we can represent the angle formed by two rays AB and AC as BAC. Angles are all around us. The hands of a clock, the slope of a roof, and the turn of a steering wheel all involve angles. Understanding angles is crucial because they form the foundation of trigonometric ratios, which we will explore in later sections. Now that we know what angles are, let's talk about how we measure them. There are two common units for measuring angles: degrees and radians. Degrees are probably the most familiar to you. We divide a circle into 360 equal parts, and each part represents 1 degree. Radians, on the other hand, are a bit more abstract. 1 radian is defined as the angle subtended at the center of a circle by an arc that is equal in length to the radius of the circle. In simpler terms, imagine you take a piece of string as long as the radius of a circle and use it to trace an arc on the circle. The angle formed by that arc is 1 radian. Both degrees and radians are useful in different contexts. Degrees are commonly used in everyday life, while radians are more prevalent in advanced mathematics and physics. It's like using centimeters to measure the length of a pencil and kilometers to measure the distance between cities. Here comes the exciting part: trigonometric ratios. These ratios are like special tools that relate the angles of a right-angled triangle to the lengths of its sides. The three most fundamental trigonometric ratios are sine, sin, cosine, cos, and tangent, tan. Let's consider a right-angled triangle. The side opposite the right angle is called the hypotenuse. Now choose one of the other two angles in the triangle. The side next to this chosen angle, apart from the hypotenuse, is called the adjacent side, and the side opposite this angle is called the opposite side, sine, sin. The sine of an angle is defined as the ratio of the length of the opposite side to the length of the hypotenuse. Cosine, cos. The cosine of an angle is defined as the ratio of the length of the adjacent side to the length of the hypotenuse. Tangent, tan. The tangent of an angle is defined as the ratio of the length of the opposite side to the length of the adjacent side. These ratios hold true for any right-angled triangle, regardless of its size. They help us establish relationships between angles and sides, allowing us to solve for unknown values. Section 5. Right-angled triangles. Putting trigonometry into action. Let's take what we've learned about trigonometric ratios and apply them to right-angled triangles. Suppose we have a right-angled triangle where we know the length of one side and the measure of one angle apart from the right angle. We can use our trigonometric ratios to find the lengths of the other two sides. For example, if we know the length of the adjacent side and the measure of the angle, we can use the cosine ratio to find the length of the hypotenuse. Similarly, we can use the sine ratio to find the length of the opposite side. Right-angled triangles are everywhere, making these trigonometric ratios incredibly useful in various fields. Architects use them to design buildings, engineers use them to build bridges, and physicists use them to study motion and forces. Section 6. Real-world applications: trigonometry in our everyday lives. Trigonometry is not just confined to textbooks and classrooms, it's all around us. Let's explore some real-world applications that demonstrate the power and practicality of trigonometry. 1. Navigation. Sailors and pilots rely heavily on trigonometry for navigation. By measuring angles and distances, they can determine their position, plan routes, and avoid obstacles. 2. Surveying. Surveyors use trigonometry to measure land, create maps, and determine boundaries. They use instruments like theodolites and total stations, which are based on trigonometric principles. 3. Astronomy. Astronomers use trigonometry to calculate distances to stars and planets. By measuring angles and using trigonometric functions, they can determine the vast distances in space. These are just a few examples of how trigonometry plays a vital role in our everyday lives. From the GPS navigation in our smartphones to the design of roller coasters, trigonometry is everywhere. Section 7. The unit circle, a powerful tool for understanding trigonometry. The unit circle is like a secret weapon in trigonometry. It's a circle with a radius of 1 unit centered at the origin of a coordinate plane. Don't let its simplicity fool you. It's a powerful tool that helps us visualize and understand trigonometric functions and their relationships. Imagine a point moving along the circumference of the unit circle. As the point rotates, we can draw a right-angled triangle by dropping a perpendicular from the point to the x-axis. The x-coordinate of the point represents the cosine of the angle formed by the radius and the x-axis, while the y-coordinate represents the sine of the angle. The unit circle allows us to extend the definitions of trigonometric functions beyond right-angled triangles. We can find the sine, cosine, and tangent of any angle, regardless of whether it's acute, obtuse, or even reflex. Section 8. Trigonometric identities, unveiling the relationships. Trigonometric identities are like special equations that are true for all values of the variables involved. They reveal fundamental relationships between trigonometric functions and allow us to simplify complex expressions. One of the most famous trigonometric identities is the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. This identity states that for any angle theta, the sum of the squares of its sine and cosine is always equal to 1. Trigonometric identities are used extensively in various branches of mathematics, physics, and engineering. They help us solve equations, prove theorems, and simplify complex calculations. Section 9. Conclusion. Embracing the power of trigonometry. Trigonometry might seem intimidating at first, but it's a fascinating and rewarding subject to learn. By understanding the basic concepts of angles, trigonometric ratios, and the unit circle, you unlock a powerful toolset for solving problems and understanding the world around you. From measuring distances in space to designing earthquake-resistant buildings, trigonometry plays a crucial role in countless fields. As you delve deeper into this subject, you'll discover even more applications and connections to other areas of mathematics and science. Remember, practice is key. The more you work with trigonometric concepts, the more comfortable and confident you'll become. So, embrace the power of trigonometry, and let it empower you to explore the wonders of our mathematical universe.